if we have a plane figure or a two-dimensional shape, there's this idea of perimeter, which if we take some shape like that, say, the perimeter is the distance around the figure. So the way that I like to think of perimeter is if you take a walk around the shape, how far did you walk? When we have a circle, we have a special word for perimeter. It's called circumference. So the circumference is just the distance around a circle. So if you walk around the circle, how far do you walk? Area is the amount of two-dimensional space that an object takes up. So it's the amount of surface covered by a figure. And now we're going to look at some formulas here for these different shapes that we can have. Let's start with squares. So a square is something that looks kind of like that. It has all four sides congruent. It also has all angles congruent, all angles 90 degrees. So for the sake of doing the perimeter and area, let's call each side S. So since all the sides are the same, we can call them all S. S for side. So the perimeter then is going to be if we just add up all of those. So we say the perimeter is equal to S plus S plus S plus S. Add those all up, and we get 4S. If you think about combining like terms there, we get 4S. So for the perimeter of a square, we just take the side length and multiply it by 4. Or in other words, add up all the four sides. For the area, well, area is length times width. On a square, those are both S. Those are both the same number. So the area here would be S times S. Well, when you multiply something by itself, we can use an exponent to talk about that. So if we have S times S, we can write that as S squared. So the exponent tells you how many times to multiply the thing by itself. And this is actually why we call the second power squared. So if you raise something to the second power, we say that it's squared. The reason is that when you square a number, you get the area of a square that has that number as its side length. So that's why we call it S squared. If you have a rectangle, it's very similar to a square, except that not all the side lengths are the same. So those two opposite ones will be the same, and these two opposite ones will be the same. Still all the angles will be right angles, but not all four sides are the same. So we'll call one of them length and one of them width. Since the opposite ones are the same, I'll label those as L and W as well. So for the perimeter then, what we would do is we would just add up all four sides. So we would have W plus L plus L. If we combine like terms again, we get 2W plus 2L. As for the area, you guys probably learned this a long time ago, but length times width will give you the area of that rectangle. And for a triangle. So I like to think of, when I'm thinking of area of a triangle especially, I know I'm skipping ahead here, but let's think about area. I like to think of this as if you were to say, well, I got ahead of myself here. Let's take a rectangle. Now, if I want to know the area of that rectangle, it's going to be length times width. Okay, so that'll give me the area all inside of there. But if I cut it in half, well, now I've cut it into two different triangles. So if I want to know, let's say, the area of this triangle here, what I would do is I could find the area of that rectangle by doing length times width, and then just cut it in half. And so this tells us that the formula for an area of a triangle is going to be if we find that area of the rectangle and then cut it in half, we'll get the area of the triangle. And so for any triangle, say like this, we've got three sides, call them A, B, and C. But we've also got the height here. So if I draw a vertical line going straight down and perpendicular to that bottom part B, we can call this the height of the triangle, call it H. So then if we take the base times the height, which is essentially length times width of a rectangle, then we can find that area and then cut it in half to get the triangle. So imagine there being a rectangle here around the triangle. If we took the height of this triangle times the length of the base there, we would get the area of that green rectangle. But we don't want the whole area, we just want the half of it. So that's going to be 1/2 the base times the height. For perimeter, again, we just add up the three sides. So we do A plus B plus C. And for a circle, well, circle has a certain radius, which a radius is the distance from the center of the circle to the outside. And that distance is the same no matter where you draw it. So if you draw a radius, here or here or here, those are all going to be the same length. We call that radius R. Now for the perimeter of the circle, perimeter is, the fancy word we have for that is circumference. So we're going to say the circumference then is actually going to be the distance straight across the circle, so from here to here, which is called the diameter of the circle. So we'll say d times pi, the diameter times pi. So pi is this circle constant that is a number that is kind of ingrained inside of circles. It helps us relate the distance around the circle to the distance through the circle. And it is related by this constant pi. So the circumference is the diameter times pi. Well, if we look at the diameter, this is really just two radii stuck together. So the diameter is really one radius going up and one radius going down there. So that's really just two radii stuck together. So we could also say that the circumference is, instead of having the diameter, it's just 2 times the radius times pi. Now it doesn't really matter, but often this is written just as 2 pi r. Really no difference between those though, again because you can multiply numbers in any order. So 5 times 2 is the same thing as 2 times 5. Doesn't matter what order you multiply them in. So we can rearrange that to get 2 pi r. If you prefer it as just 2r times pi, that's fine too. Doesn't really matter. As far as the area goes, we're going to use pi again. This time area is pi times the radius squared. So we do not use the diameter for area, just the radius. Example 1. Find the perimeter and area of a rectangular basketball court with a length of 84 feet and a width of 50 feet. Well, if we want to find the perimeter, we just add up all the side lengths. So we would do 84 plus 50, but we have to make sure to include these other two as well. So plus 84 plus another 50. Well, if we add all that together, what we get is 268. So the perimeter, adding up all the side lengths, is 268. For the area, that's going to be the amount of two-dimensional space that this rectangle takes up. What we do is we take length times width. So the area is going to be 50 times 84. 50 times 84 is 4,200. Example 2. You are ordering circular cloth patches for your soccer team's uniforms. Find the approximate circumference and area of the patch that has a diameter of 9. So the distance straight through the center is 9. Before we go any further, let's figure out how long the radius is. So the radius, again, is the distance from the center to the outside. So like I said before, the diameter is really twice the radius. It's like having two radii stuck together. So if we take 9 and cut it in half, we're going to get the radius, which is 4.5. All right, now let's look at circumference and area. So circumference is pi times the diameter. So we don't need to use that 4.5 quite yet, but we would do 9 times pi. Now sometimes I will ask you to leave the answer in terms of pi, which means that you would leave it just like this, as just 9 times pi. And sometimes I'll have you get an approximate answer, so we'll use squiggly equal sign here. And for this, we're just going to have a rounded off answer. So remember that pi has infinitely many digits in it. There's no end to the digits in pi. And so if we multiply 9 by pi, well, we're also going to have infinitely many digits there. And so there's no way we can actually write this actual number that 9 times pi would be. But we can at least throw it into the calculator and round it off to some decimal. And actually, to be clear, even your calculator couldn't figure that out, because your calculator may have a lot of digits of pi in it, but it does chop it off somewhere because your calculator can't hold an infinite amount of information in it. So when we do something like 9 times pi, we've got to chop it off somewhere. So this is approximately 28.27. Now for the area, again we use pi. This time we use the radius though, radius squared. So we do pi times the radius squared. That's going to be pi times 4.5 squared. So again, sometimes I would have you leave it in terms of pi. So if I'm having you leave it in terms of pi, you could figure out the 4.5 squared. That would be 20.25. And then leave it times pi. So that would be if I'm asking you for an answer in terms of pi, or if I ask you for an exact answer, that's going to be something like that. If I ask you for a rounded answer, or if I ask you just to get an approximation for it, then you could take 20.25 multiplied by pi, and you get approximately 63.62 after rounding. Example 3. We've got 3 different points on the graph here. So one of them is 1, 2. That's right here. One of them is 4, 6. That's right here. And one of them is 5, 2. That's right here. So what we're going to do is draw a triangle between these. We want to know the perimeter of the triangle. So what we've got to do is find the length of each of these sides. Well, this one right here is easy to count. That one's just 2. But the other 2 are diagonal. So we've got to be a bit more careful about how we figure this out. Now, we could use the Pythagorean theorem, or we could use the distance formula. I will write the distance formula here if you want it. So if you would like to use the distance formula, you're welcome to do that. You basically just take the coordinates and plug them in. So you'd subtract the 2 x values right here, and then square it. Then you subtract the 2 y values here, and then square it. And then add those together and take the square root. Now that is a messy, long formula. I prefer to just use the Pythagorean theorem, because the distance formula really just does the Pythagorean theorem for you. But for me, it's easier to keep straight in my head just doing the Pythagorean theorem. But there really is no difference between using the distance formula and using the Pythagorean theorem. So what I mean by using the Pythagorean theorem is that we're going to take 2 points. So if I want to, say, find the distance between these 2 points here, I can draw a right triangle where the sides of that right triangle are aligned perfectly on the grid, so that this piece of the right triangle is 1, and this piece is 1, 2, 3, 4. So now we've got a triangle that has side lengths of 1 and 4. It's a right triangle, so we can use the Pythagorean theorem. Say if I call that side length c, I could say that c squared is equal to 4 squared plus 1 squared. Go through and solve this for c. And again, if you go through and solve this for c, you are doing exactly what the distance formula is. It's just kind of disguised within all of that square root and squaring and parentheses and whatnot. All right, so the first thing to do then is to take care of each of these squares. So 4 squared is 16. 1 squared is 1. It's just 1 times itself, 1 times 1. Add those together and we get 17. But we don't want c squared, we want c. So let's take the square root of both sides, and we get c equals the square root of 17. Now that is going to be a decimal number, but let's leave it as the square root of 17 for right now. And then we can do the same thing up here with this one, with the distance between these 2 points, to find, say if I call this one d, I can find that variable d just by using the Pythagorean theorem again. So this distance on top is 3. This distance from up and down is 4. So we can say d squared is equal to 3 squared plus 4 squared. Go through and solve this. 3 squared is 9. 4 squared is 16. Add those together, you get 25. So d squared is 25. But again, we don't want d squared, we want d. So let's square root both sides. And we get d equals the square root of 25, which again, if you're doing a square root, I like to think of this like a question. So the square root symbol, that's asking you what number multiplied by itself gives you 25. That number is 5. So this distance here is 5. So now we've got a triangle that has one length of 2, one length of 5, one length of square root of 17. So we could write this, 2 plus 5 is 7. We could write this as 7 plus the square root of 17. Or we can grab our calculator and find a decimal approximation. So 7 plus square root of 17 in the calculator gives you approximately 11.12. So either one of those would be an acceptable answer. Example 4. An ice resurfacing machine is used to smooth the surface of the ice skating rink. The machine, let me get that out of the way. The machine can resurface about 270 square yards of ice in 1 minute. How many minutes does it take the machine to resurface a rectangular skating rink that is 81 yards long and 20 yards wide? So 81 on one dimension, 20 on the other dimension. And we want to know how many minutes it takes. Well, before we figure out how many minutes it takes, let's figure out what the actual area is. So we can resurface 270 square yards in 1 minute. So to figure out the time, we first need to know how much area there is there. So for the area, we just take length times width. That's going to be 81 times 20. And the total area is 1,620 square yards. All right, well, it can do 270 square yards in 1 minute. And so if we want to know how many minutes it's going to take to do 1620 yards, we can divide. So we can take that total area and divide it amongst the 270 yards that it can do every minute, and that'll tell us how many minutes it will take. So 120 yards, square yards, and then divide that by 270 square yards per minute. Well, this is going to be 1620 divided by 270 is 6. And then, well, here with the units, we have yards squared divided by minutes. That's yards squared per minute. So the yard is on top, yards on bottom will cancel. We'd be left with 1 over the minutes on the bottom. Well, if we're dividing by 1 over the minutes, remember that dividing is the same as multiplying by the reciprocal. So if we take the reciprocal of 1 over minutes, that's going to be just minutes, and so we get 6 minutes. Last example. Base of a triangle is 28 meters. Its area is 308. It says find the height. Okay, so the height is going to be the distance here in green. Well, we don't know what that is. We'll call it h. But what we can do is we can just set up the formula and then solve for h. So we know that the area is equal to 1/2 the base times the height. So if we know that the area is 308, we can plug that in. And we know the base is 28, so we can plug that in. We don't know the height, but that's what we're trying to find, so we can just leave that as h. And then we solve this equation. So on the right side, 1/2 times 28, that's 28 divided by 2, is 14. Then to get h, we just take both sides and divide it by 14. We get h equals 22. So the height is 22 meters.